Now we're going to show that the combined effect of a reflection in the line y equals x followed by another reflection in the line y equals 3x is the same as performing some sort of rotation about the origin. Let's have a look at our first transformation. So T1 is just going to be a reflection. So we've got a reflection about our mediator line. So M y equals x. And when we reflect about y equals x, 1, 0 becomes 0, 1, and 0, 1 becomes 1, 0. Okay. Our second transformation is a reflection about the line y equals x tan of theta, and we need to figure out what our angle is. And we know that m, our gradient, is equal to tan theta, so root 3 is equal to tan of theta. And from our triangles, we know that tan of theta is equal, tan of 60 is equal to square root of 3, so therefore theta is 60 degrees. Also, our transformation matrix for a reflection about the line y equals x tan theta is given to us on our formula sheet, and that's cos of 2 theta sine of 2 theta sine of 2 theta and negative cos of 2 theta. Now theta is 60 degrees. What we've got cos of 120 degrees, sine of 120 degrees, sine of 120 degrees, and negative cos of 120 degrees. Let's quickly look at our cast diagram to figure out our negatives and positives. So if we draw our 4 quadrants, 120 degrees, if this is 0 and clockwise from 0, is in our second quadrant. So there's 120 degrees, and my acute angle is 60 degrees in there. So cos of 120, well, cos is negative in quadrant 2, and cos of 120 is the same as cos of 60, or negative cos of 60, so that becomes negative a half. Sine of 120, well, sine is positive in quadrant 2, and sine of 60 is root 3 on 2. Sine of 120 is the same as sine of 60, so root 3 on 2. And negative cos of 120, well, we've already established that cos of 120 is negative a half, so negative a half times negative a half is positive a half. All right, let's have a look now. We're going to have to do our transformations in the reverse order that they happened. So we've got negative a half, root 3 on 2, root 3 on 2, positive a half, and we're multiplying that by 0, 1, 1, 0, and that gives us another matrix that is root 3 on 2, negative a half, root 3 on 2. Now you need to use what you know about your exact trig ratios to figure out what these could be in terms of a trig ratio. So having a look at my exact values, because I can see they're all halves and root 3s on 2s. There's my 60 degrees, there's my 30 degrees, 1, 2, and square root of 3. Well, root 3 on 2 can either be sine of 60, or it can be cos of 30. So I guess if we're going to go with 60 degrees, remember we need to get our angles the same for a rotation, because our equation given to us on our formula sheet, r theta, is going to be cos of theta negative sine of theta, sine of theta, cos of theta. Okay, so I'm going to have to find ratios where I've got exactly the same angle. So I'll start with cos of theta is root 3 on 2. Can you see there? There's my cos of theta. It has to be root 3 on 2. Well, cos of theta is root 3 on 2 gives me that theta is inverse cos of root 3 on 2. So theta is 30 degrees. Okay, let's check that sine of theta, which is going to be, let's take that one there, has to be equal to a half. Okay, and so that means that theta is going to be inverse sine of a half. And if I have a look here, well, sine of 30 is also going to be a half. Okay, and similarly with the others, I've got a negative sine of theta. Well, that gives me negative a half. I've already shown that sine of theta gives me a theta of 30 degrees. So therefore, a rotation of 30 degrees about the origin would be cos of 30 degrees negative sine of 30 sine of 30 cos of 30, which is what we have. And we've shown that above.